Hello friends and welcome to my channel. In this video I am going to talk about the influence of diameter and length of the intake path in an internal combustion engine. So let's start. The air-fuel demand of an internal combustion engine varies with respect to the engine RPM. So, for efficient operation, we have to provide the exact amount of air and fuel at the exact RPM. At low engine RPM, we need higher intake air velocity to create turbulence and for proper mixing of air and fuel to create a homogeneous mixture. And in this region, we have enough time to create a homogeneous mixture, which means we need higher velocity and higher turbulence in the low engine RPM, and what we need at higher engine RPM is higher flow rate and low velocity. So for satisfying the internal combustion engine in its all RPM ranges, we have to change the intake path as well as the valve train to satisfy the engine in all its rev ranges. So how we are able to provide these higher flow rate and higher velocity in the intake according to the RPM. The VVT or variable valve timing technology will help us to give some modification in the intake air flow, but not at the level we need. This is why we have to change the radius or diameter of the intake path and the length of the intake path. This equation is the Hagen-Poiseuille equation. Delta P is the pressure difference, mu is the dynamic viscosity, L is the length of the pipe, Q is the discharge or flow rate, and R is the radius of the pipe. If we rearrange this equation to find the flow rate, we can directly see that the flow rate is directly proportional to the fourth power of the radius of the pipe or the diameter, and we can see that the length is inversely proportional to the flow rate, which means we can simply increase the flow rate by increasing the diameter of the pipe or by reducing the length, which means higher length means lower flow rate. So if we modified our engine's intake path to get higher flow rate by reducing the length and by increasing the diameter of the pipe or intake path, we will have higher flow rate. But we doesn't need the higher flow rate at low engine RPM, which I already said. So we have to do some modification or do some flexibility in the path. This is why performance car engine have two intake paths. One is a shorter one and one is a longer one. The longer one will be used at low rev range and the shorter path will be used for high rev ranges for getting higher flow rate and lower velocity and to fill the combustion chamber with excess air to produce the power we need. So with the shorter path we can satisfy the engine at high engine RPM, so we can produce higher power with high rev. For getting the advantages of shorter path and longer path, we need a flexible cylinder head design. So this is a great achievement if you are able to interchange between these two paths, and we will have most flexible system if the path is able to change according to each RPM variation, and it is a very great achievement. In Camrus engine you might be noticed that there will be two type of intake path with various cross-sectional area, and I have already said the influence of cross-sectional area in the intake path. So if you learned about the influence of length and diameter in the intake path, please leave a thumbs up and don't forget to subscribe to my channel because more interesting videos are coming, and hit the bell icon to get notified when I make a new upload. Thank you for watching. In the actual case, the more satisfying equation for the flow rate is the Darcy-Weisbach equation, but for simplicity I have considered this equation. Hope you enjoyed it. If you want to learn more about Darcy-Weisbach equation, please leave a comment below. I will do one video on that. Thank you for watching again. Bye.